We have a function f which is a function of two variables, and it is given by this particular expression. So we need to show that the second partial derivative of f with respect to x plus the second partial derivative of f with respect to y equals to 0. So let's begin. So here we are given the function f, which is log of x squared plus y squared added to the inverse tangent of y over x. What we'll do, we'll take the partial derivative of our function f with respect to x. That means we have to take the partial derivative with respect to x of each of the terms on the right hand side. So we have log of x squared plus y squared plus partial with respect to x of the inverse tangent of y over x. Right. Now we know that the derivative of the logarithmic function, so that simply equals to 1 over x. Right. So this gives us 1 over x squared plus y squared, and this will be multiplied to partial with respect to x of x squared plus y squared. So here we have used the chain rule. Plus, then we take the derivative of the inverse tangent function, the ddx of tan inverse of x. So that's given by 1 over 1 plus x squared. So that means we have the partial derivative of the inverse tangent function of y over x will be 1 plus y over x whole squared multiplied to, using the chain rule, we have partial with respect to x of y over x. So this gives us 1 over x squared plus y squared times the partial of x squared with respect to x plus partial of y squared with respect to x plus x squared divided by x squared plus y squared. So here, since we are taking the partial derivative with respect to x, so y will be treated as a constant. We'll pull the y out, and we have to take partial with respect to x of 1 over x. So that means we now have 1 over x squared plus y squared times the partial of x squared with respect to x will be 2x plus partial of y squared with respect to x will be 0 plus x squared times y divided by x squared plus y squared times partial with respect to x of 1 over x. So that's negative 1 over x squared. Fine. So this is partial derivative of f with respect to x. So let's simplify. So we'll get partial with respect to x equals to 2x divided by x squared plus y squared. So here x squared and x squared cancels out, and that leaves us with negative y divided by x squared plus y squared. We'll combine the numerator because the denominator is common to both of them. So this gives us partial of f with respect to x equals to 2x minus y divided by x squared plus y squared. Now again, what we'll do, we'll take the partial derivative on both sides with respect to x. So we have partial with respect to x of partial of f with respect to x, which will be equals to partial with respect to x of 2x minus y divided by x squared plus y squared. So this gives us the second partial derivative of f with respect to x, which will be equals to, so on the right hand side, we'll use the quotient rule. Starting with the denominator, we have x squared plus y squared whole squared. In the numerator, we have x squared plus y squared. So this will get multiplied to partial with respect to x of 2x minus y minus 2x minus y times partial with respect to x of x squared plus y squared. Right. This will be equals to x squared plus y squared multiplied to, we will take the partial derivative of 2x with respect to x, so that's simply 2, minus partial of y with respect to x will be 0 because y is a constant, minus 2x minus y times partial of x squared will be 2x plus partial of y squared will be 0 divided by x squared plus y squared whole squared, which is 2 times x squared plus 2 times y squared minus, so 2x times 2x will be 4x squared positive y times, so this will be 2xy, whole thing divided by x squared plus y squared whole squared. So that means we now have the second partial derivative of f with respect to x. So this will be equals to 2y squared minus 2x squared plus 2xy divided by x squared plus y squared whole square. So we will now label this as equation number 1. We will use this. So this is also f(x), x. Fine. Now we will start with the second one. We'll find out the second partial derivative of f with respect to y. We will start with the function f. We'll take the partial of f with respect to y. That means we'll have to take the partial derivative of log of x squared plus y squared with respect to y. So that means we get y over 1 over x squared plus y squared multiplied to partial with respect to y of x squared plus y squared, plus partial derivative of inverse tangent function will be 1 over 1 plus y over x whole squared multiplied to partial with respect to y of y over x, which will be equals to, so partial of x squared will be 0 and partial of y squared with respect to y will be 2y. So we get 2y divided by x squared plus y squared, plus we have x squared divided by x squared plus y squared. So since we are taking the partial derivative with respect to y, and 1 over x will be a constant, we can take 1 over x out, and we are left with partial of y with respect to y, which is simply 1. The x and 1x from the numerator into denominator goes away. So this gives us 2y plus x divided by x squared plus y squared. So this is the value of partial of f with respect to y. Now let's take a partial derivative on both sides with respect to y, which gives us the second partial of f with respect to y, which will be equals to, so we'll use the quotient rule here. Then the denominator we have x squared plus y squared whole raised to the power of 2. In the numerator we have x squared plus y squared times partial with respect to y of 2y plus x minus 2y plus x multiplied to partial with respect to y of x squared plus y squared. That's going to give us x squared plus y squared multiplied to partial of 2y will be 2 minus 2y plus x multiplied to partial of y squared with respect to y will be 2y divided by x squared plus y squared whole squared, which gives us 2x squared plus 2y squared minus 4xy minus 4y squared minus 2xy divided by x squared plus y squared whole square. So this is second partial derivative of f with respect to y, which will give us fyy equals to, so here we have 2x squared minus 2y squared minus 2xy divided by x squared plus y squared whole square. Now let's label this as number 2. Now in equation number 1, we obtain the second partial of f with respect to x equals 2y squared minus 2x squared plus 2xy divided by x squared plus y squared whole square. So if we take negative as the common factor, then in the numerator we will have 2x squared minus 2y squared minus 2xy divided by x squared plus y squared whole squared, and this entire term within the parentheses can be replaced with equation number 2. So we will have fyy. So that means f(x) equals f negative fyy, or in other terms we can say that the second partial derivative of f with respect to x added to the second partial derivative of y with respect to y will be simply equals to 0. So this is what we were asked to prove.